Hi everyone, so it's Coach Fred here talking about literal equations. I'm calling it that because I'm guessing that's the way your teacher might have taught it to you in Algebra 1. A literal equation is just that, it's really a formula. So maybe you might be really familiar with like D equals R times T, distance equals rate times time. And you want to be able to manipulate equations sometimes because D equals R times T is really easy if I tell you that the rate is 20 and the time is, I don't know, 10, right? Then you can find the distance. But sometimes you're given the rate and the distance, and you're trying to find the time. So you want to be able to modify equations, even easy ones, for other variables. So you do the same thing you do if these were numbers. So let's say I wanted you to solve for t. Well, then I could divide both sides by r. So then d over r equals t. So then if I was given the distance and the rate, I could plug them right in to get the time. So that's what we mean when we're talking about literal equations. It means that we're taking a formula and expressing it in terms of other variables, okay? So here's a really great example. It asks you which equation is equivalent to 3x plus 4y equals 15. Well, through your summer work, you might remember this is a linear function, or a linear equation, and it's in standard form. But there's two other equivalent forms of that same linear equation, point-slope form and slope-intercept form. So you could be asked to solve for y in terms of x. That means y equals, get it into y equals form. So what would you do? Well, first, to isolate the y, subtract 3x to the other side. So 4y equals 15 minus 3x, and then you divide by 4. And you get y equals 15 over 4 minus 3 over 4x. So you can see that's actually in y equals mx plus b, or y equals b plus mx. So we moved it around. We didn't solve the equation. We solved the equation in terms of another variable. All right. Can get a little trickier. That one had numbers in it. This one doesn't. It says, okay, if EY over N plus K equals T, what is Y in terms of E, N, K, and T? It means solve for Y, basically. Okay, so we need to isolate Y. So I'm actually going to rewrite it right here so I can see it better. Okay. All right. So the first thing that you'd want to do is get the k to the other side because you're going to try and isolate y. So I'm going to subtract it to the other side. So now I have EY over N equals T minus K. All right. So right here, we want to get y alone. We have this fraction we're dealing with. So I'm probably going to multiply both sides by N, the lowest common denominator, to clear the fractions. So that's going to give me EY equals T minus K times N. Now I could put the N in front, it doesn't matter. The commutative property allows me to do that. All right, so now E and Y are being multiplied. So to get rid of the E, to get E to the other side, I'd need to divide it on both sides. So I'm going to divide both sides by E. And so that gives me Y equals, and I'm going to move that N, T minus K over E. And so I look for my answer, and there it is, right here. I know it's challenging, but always just ask yourself, what would you do if these were numbers? Okay? And let's look at some harder ones. Okay, here's one. A formula for calculating velocity. You might have done this if you took physics. So the velocity formula is velocity equals 1/2 at squared. So what is a expressed in terms of v and t? Okay, that just means solve for a. Okay, and in this case, I kind of noticed the answers even are all solving for a. All right, so we've got this formula, and we've got some things we want to do to get a alone. So I actually tend to do them in parts. I saw that fraction. I want to get rid of it, so I'm going to multiply both sides by 2. Okay, so 2v equals at squared. All right, t squared is being multiplied to a, so to get rid of it or to get it to the other side, I'm going to divide by t squared. And so 2v over t squared would be my a in terms of e and t. All right, we're going to try one more, okay? A little bit trickier one. So if a plus ar equals b plus r, what is the value of a in terms of b and r? Okay, now what you might notice is that you have a in two different terms here. Now, if we look at the other ones, the variable we were solving for, like y here, and a here, they were only in one term of the equation. Here, I have it here and here, an a. So I tend to think about that and see if they're in two terms, then they are a common factor. So one way to think about that is I can pull out an a on this left side of the equation. That's going to give me 1 plus r equals b plus r. Then I have this term being multiplied to a, so to get it to the other side, I'm going to divide it. I'm going to do the inverse operation. And so that will cancel. And so I would get b plus r over 1 plus r. All right, hopefully that helped you and will help you on your summer work as you complete these literal equations. Again, if you get confused, think about what you would do if you had numbers. And usually that can help you a little bit, okay? All right, have a great day.